Hi ladies, so today, this is going to be the last new video. We're going to do mass-to-mass conversions with stoichiometry or chemical reactions. Okay, so review real fast that a balanced chemical equation gives you the moles of each substance in the reaction. And the coefficient, more specifically the coefficients tell you the moles of each substance. You always use the mole ratio when you switch between compounds. So it's a must step. So I went and I stuck the mole road reduced down to the simplest. Yes, baby. Okay, so all these little arrows are just going to pop up randomly. Well, I think they are. Yeah. I'm just going to click. Okay, so by reducing it down, I want to click that last. So like, you need a pencil. So like, okay, so all these arrows are going in because that's what's going to happen. Any of these outside lines is where you would start. Granted, when we did this before, we only did mass and volume of a gas. But like, okay, so when you go from mass to mole, you do 1 mole over the molar mass of that compound. And then you have moles, and then you do the mole ratio, and then, like, once you switch to the other compound, like, that's what the conversion vector is going to look like with just, you know, the coefficients written there. And then once you're in the other compound, then you're going to move out to something, to mass or volume, or that's solutions. I mean, that's something we just didn't do. Or to particles, which we also didn't do because nobody cares. But there you go. This is the mole ratio step. And then I just simplified it down really to the 4 steps. So when you go, and it literally, you go left to right. So this would be compound 1 over here. If it starts with mass. So any of these boxes is a starting point, and then the lines in the middle would be like the steps on the grid. So from mass, you divide by molar mass, or, you know, and then you'll have moles of that other compound. And then you'll do this. Okay, so that's a lie. Like, you're not going to have you don't have to do a separate calculation. You could just do all one road. But as soon as you're there, then you do mole ratio, and then mole ratio, and then you do, if you ask for mass, you go out to the other compound. So this is a really old one. Most important things to do is follow the steps. So like steps, you have to read. Mole ratio must be one of your steps now. And mole conversions will be another step. And I really should have had this. You must read and by follow the steps. So here's our setup one more time. And I would like, easiest way is actually write this over here, what you want to solve for, what you're starting with, and then conversions. And this is now going to be more than one step. Why do we write this over here? Because what happens is what you want to solve for is going to that unit, and chemical is going to be in this top corner at the end. So examples, like I got 3 examples. So here's our equation. And our problem, right? So I did the color coding thing again. So first off, what are we solving for? And again, don't think too hard. How many moles? That is a question. That's what you're looking for. Moles of AgCl, silver chloride. And then the other thing, number with unit and chemical, is what you're starting with. So 3.7 grams of MgCl2. So that's what we started with. So now I don't want to go back because it's going to erase all my stuff. Well, I guess I could. Really fast. So we're starting here. So the first thing is to do that step, and then that step, and I think that might be where it ends. Yep. Okay, so I did the molar mass already, but if you want to know, I actually don't know what Mg is, but Cl is 35 plus 35, so that's 72, so whatever, magnesium, whatever is left, 22. I already did the molar mass, so that's the molar mass of MgCl2, and 1 mole of MgCl2, and then mole ratio, which is, I don't know if I underlined it, but I didn't. It would be that number and that number, right? So then moles cancel, and then it's 3.7 times 2 divided by 94, which is 0.78, or 0.078 moles of silver chloride. Well, I guess I can leave that there. Okay, so example 2, same equation. I didn't do anything with a different equation. You will have a couple problems with different equations today, but I give them to you already balanced and everything. So now, next question. Now we start with moles and go to grams. So what are we looking for? How many grams of silver chloride? What am I starting with? 0.27 moles of magnesium chloride. So you start with moles. So you just skipped over the grams to mole step. So right now, then we use mole ratio. And magnesium chloride and silver chloride. Did I just do the exact same chemicals? So mole ratio, 2/1. Silver chloride is 143 grams over 1 mole. I hope I didn't just go too fast, but I may have. So as soon as you do mole ratio, then you do grams to moles, and then multiply across the top, divide by the bottom. It'd be 77 grams of silver chloride. All right, last one real fast. So guess what? This one's going to do the whole chart. So if I have 3.7 grams of silver nitrate, how many grams of magnesium nitrate will I make? Again, that's what you're looking for, and grams MgNO32. Notice how the line is longer, so our starting is 3.7 grams of silver nitrate, and then so grams, so you do mole mass, grams to moles. Silver nitrate is 170 grams, 1 mole on top. As soon as you're in moles, so grams and grams cancel, now we're in moles. So now we do mole ratio, 2 and 1, so 2 on the bottom, 1 on top. And then, okay, so now this is the whole thing. Lots of people, because last time we only had like 2 conversion steps, but that unit and that unit are not the same. So we have 1 more step. Like, that's what I mean. Your molar mass magnesium nitrate, which is 148 grams. Moles cancel. And so 3.7 times 148 divided by 170 divided by 2 gives you 1.6 grams of magnesium nitrate. And then I think I have 4 practice problems. And it's like exactly like this. Moles to grams, grams to moles, grams to grams, probably a couple of those. So you're going to at least have 2 conversion steps, sometimes 3, in all of these. So good luck. Again, last thing.